Hello friends, welcome to today's lesson. In this video, we're going to be discussing sets and its properties. So what is set? Set is simply the collection of well-defined objects. And when I mean objects, there can be members, there can be things or objects, and then there can be places, and there can as well be human beings, right? Now, example of a set, let's say that P is equals to 1, 2, 3, and then 4. Now, this is an example of a set because it contains well-defined objects. In this case, it contains numbers, right? Now, if you have something like Q, then we have 1, 2, you have chair, and then you have a name such as Kingsley. Now, this Q here is not a set because the members of this set, which are the elements, are not well defined. You understand? It contains figures or numbers, it contains objects, and then it contains name of a person. So it can't be a set. A set must be well defined. It contains objects, it contains only numbers, or only names of human beings. Alright, so this is not a set. Now, let's discuss universal sets. Now, let's discuss universal sets. It is denoted by U, and it is the mother set from which other subsets emerge. Now, for example, assume that this universal set contains the following elements: 2, 4, 6, and 8. Now, other sets can emerge from this set, and those sets are called subsets. For example, if P is a subset of this universal set, then P may be equals to 2, 4, and 6, or it may contain the following elements: 4, 8, and 2. For the fact that this P is a subset of this universal set, all the elements it must contain must be found in the universal set. So that's what makes P the subset of this universal set. Now, another property we're going to be looking at is singleton set. Singleton set. Now, these are single element sets. So these are sets that have single elements. Now, for example, assume you have that A is equals to, then the elements of this A is made up of X, such that X is the president of America. Now, if you want to list the elements of this set, it is going to be equals to Trump, right? So there can never be two presidents at a given point in time, right, in any country. So there must be only one president. So that is one example of singleton set. Another example is the fact that in a school you can find only one principal. So that set is also a singleton set. Now let's discuss null or empty sets. Now, a null set or empty set is a set that contains no element. Alright. Now, for example, let's say the set W contains Y, such that Y is the set of a JSS1 student who is a principal, right? So Y is the set of a JSS2 student who is a principal. Now, if we want to list the elements of this set W, we can see that there is no JSS2 student who is a principal in any secondary school. So this set is equals to empty set or no set, and it is denoted by this, alright, or this, that is two curly brackets with no elements. So is either you go with this or you go with this. So also take note that this is not an empty set or no set, because this 0 is an element, alright. So this is not an empty set. This or this is what you can use to represent an empty set. Now let's discuss equal sets. Alright, now two sets are equal if they contain the same elements. Order of arrangement doesn't matter. For example, if X contains these elements A, B, C, and D, and Y is made up of the following elements B, D, A, C, and D. Now, if you look at these two sets, set X and Y, you see that set X has A, B, C, D, while set Y has B, D, A, C, and D. Now, another thing you notice is that this D is repeated, right? It appeared twice, whereas it appeared once here, but then that doesn't matter. Alright, so far this D is in this set X, is one of the elements of this set X, then it doesn't count. Okay, so you see that set X is equals to set Y. Do you get? Now let's discuss equivalent sets. Now for equivalent sets, let's assume that A contain the following elements. We have 1, 2, 3, and 4, and then B is made up of the following elements A, B, C, and D. Now how can we tell if A is equivalent to B? Okay, now if you look at set A, you see that it is made up of 4 elements, and set B is also made up of 4 elements. So for the fact that set A and B has equal number of elements, then we say that set A is equivalent to B. Alright, because we can pair them, and after the pairing, no elements will remain in either set A or set B. So because of that, we say that set A is equivalent to set B. Now, as when you have set C as 1, 4, 5, 6, and 7, is set A equivalent to set C? The answer is no. This is because set A is made up of 4 elements, whereas set C is made up of 1, 2, 3, 4, 5 elements. Alright, and set B is also not equivalent to set C, because set B has 4 elements, whereas set C has 5 elements. So this is how to tell if two sets are equivalent or not. Now let's discuss union of sets. Now assuming you have A equals to 1, 2, and 3, and then B is made up of the following elements 2, 4, and 6. Union of sets is denoted by U, right? So A union B here is going to be equals to, we're going to combine the elements of set A and set B without repeating any one. So if you combine these two sets, you see that we have 1, then we have 2 here, we have 2 here. We pick one of them, so which is 2, no repetition. We have 3 here, then we have 4 here, and then we have 6 here. Alright, so this is what union of sets is the combination of two sets without repeating any element. Even though they appeared more than twice or thrice, we don't repeat the elements. Now what about intersection of sets? So also given these two sets, the intersection of sets is denoted by n, right? So we have A intersection B. This is equals to, now you check set A, the elements of set A and the elements of set B. Do the two sets have anything in common? Now if you look at set A, you see that we have 2 here, and set B also we have 2 here. Now for the fact that they both have common elements, that element is going to be the intersection. So A intersection B is going to be equals to 2. Now the difference between union and intersection is that union is the combination of the two sets without any repetition, whereas A intersection B is just choosing any one that appeared in both sets. Alright, that's what intersection means. Now let's discuss complements of sets. Now as when we are given this universal set 2, 4, 6, 8, and then we have subsets P. Now this P is a subset of this U, and it is made up of the following elements 2 and 6. Now if you are told to find the complement of P, often denoted as P complement, this is going to be equals to, now you come to this universal set and subtract the elements that are in this subset P from the universal set. Alright, you have 2 here and we have 6 here, so we're going to eliminate 2 here, we're going to eliminate 6 here. What are the remaining elements? They are 4 and 8, so we have 4 and 8. Now this 4 and 8 is the complement of P. Alright, so this is how to determine the complement of sets. Now let's discuss disjoint set. Two sets are said to be disjoint if they don't have anything in common. So that is to say that if their intersection is equals to empty set, then that two sets are disjoint. For example, let's say that we have two sets Q equals to 1, 2, and 3, and then R is equals to, or rather made up of the following elements 4, 5, and 6. Now if we try to find the intersection of these two sets Q intersection R, this is going to be equals to empty set. Alright, because they don't have anything in common. 1, 2, 3, 4, 5, and 6. So there's no element that appeared in set Q and also in set R. So we say that the intersection is empty set, or we can also write it as two curly brackets with no element inside. So because these two sets has no intersection, they are called disjoint sets. Now what if they have intersection, just like in this case? So if they have intersection, they are called non-disjoint sets. That is, their intersection, let's say Q intersection R, is not equals to empty set. Let's discuss power set. Now, power set is the collection of all the subsets of a given set, right? So, as when you have set A and is made up of the following elements 1, 2, and 3. What is the power of this set? Now the power of this set is given by 2 raised to the power a. Alright, this is equals to 2 raised to the power, where a is equals to the number of the elements in this set. So in this case, a is made up of 3 elements, that is 1, 2, and 3 elements. So this is going to be 2 raised to the power 3, which is equals to 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is equals to 8. So the power of this set is equals to 8. And what does it tell us? It tells us that this set A has 8 subsets. Alright, now how do we write out the 8 subsets that are in this set A? We're going to start with the subset that has only one element, and we're going to be making use of combination. So because the number of elements here is 3, we're going to write 3 combination. Then the number of sets with one element, we write 1 here, right? So 3 combination 1 is given as 3 factorial divided by 3 minus 1 factorial multiplied by 1 factorial. So 3 factorial is equals to 3 times 2 times 1 divided by 3 minus 1 is equals to 2. 2 factorial is equals to 2 times 1. Then multiplied by 1 factorial is just 1. Alright, 3 times 2 is equals to 6. 2 times 1 is equals to 2. 6 divided by 2 is equals to 3. So the subset of one element is equals to 3. So how we are going to write it? So it's going to be equals to 1, then 2, and 3. So these are the subsets of the one elements we found. They are equals to 3. How about the subsets of 2 elements? We're just going to replace 1 here with 2, right? And then if we do that, we're going to have 2 here. It's going to be equals to 2 minus 1. Then we have multiplied by 2 factorial. This will be 2 factorial. So we have 3 factorial already is equals to 6 divided by 2 minus 1 is equals to 1 multiplied by 2 factorial is equals to 2. So 6 divided by 2 is equals to 3. So the number of subsets with 2 elements are also equals to 3. And here are they. So you have 1 and 2. Then we have 1 and 3. And then we have 2 and 3. Now let's calculate the number of subsets with 3 elements. So we have 3 combination, the number of subsets with 3 elements, right? So 3 combination 3, we have 3 factorial divided by 3 minus 3 factorial multiplied by 3 factorial. So 3 factorial is equals to 6 divided by 3 minus 3 is 0. 0 factorial is equals to 1 multiplied by 3 factorial is equals to 6. So you have 6 divided by 1 times 6 is 6, and then 6 divided by 6 is equals to 1. And then the remaining subsets is given by 1, 2, and 3. So let's count it. We have 1, 2, 3, 4, 5, 6, and 7. But we say that the power of this set is equals to 8. That's to say that it contains 8 subsets. But then we have 7 subsets here. What happened to the 8th one? Now the 8th one is simply the empty set. So you have to include empty sets. Right, so that is the 8th one. And this is the end of this video. Thank you for watching. Please don't forget to subscribe to this channel, like this video, share with your friends, and drop a comment. Have a nice day.